For months, astronomers assured us that 3I/ATLAS would be nothing more than a spectacular flyby, a harmless interstellar visitor skimming past Mars and vanishing into the cosmic black. But the universe has a way of surprising us, doesn't it? And now, with fresh data pouring in from our most advanced telescopes, the story is unfolding in ways that blend cold, hard science with tantalizing questions about what's out there. James Webb, our sharpest eye on the void, has captured details that reveal this comet's secrets, its ancient origins, its wild speed, and why it's got the whole space community buzzing. This isn't just about a comet zipping by, it's about peering into another star system's past, understanding how these rogue wanderers shape our solar neighborhood, and pondering what else might be hitchhiking on cosmic ice. Stick with me as we dive deep into 3I/ATLAS, the third interstellar object to grace our skies, the largest we've seen yet, and a frozen time capsule hurtling at speeds that make your head spin. Why does it matter? Because every interstellar visitor rewrites the rules of space exploration, reminding us that we're not isolated, we're part of a galactic conversation. Let's unpack this step by step, from its dramatic entrance to the mind-bending data that's changing how we see the stars. Picture this. It's July 1st, 2025, and a routine scan from the Atlas telescope in Chile picks up a faint streak slicing through the night sky. At first, it looks like your garden-variety comet, but the math doesn't add up. This thing's moving too fast, about 87 kilometers per second relative to the sun, and on a path that's not looping around our star like a local. No, it's on a hyperbolic trajectory, screaming in from outside our solar system and destined to sling right back out. That's when the excitement hits. We've got our third confirmed interstellar object after the enigmatic Oumuamua in 2017 and Borisov in 2019. Named 3I/ATLAS for its discovery by the Asteroid Terrestrial Impact Last Alert System, it's already proving special. Unlike Oumuamua, which was cigar-shaped and silent, or Borisov, a more traditional comet with a visible tail, 3I/ATLAS shows up with a glowing coma, a hazy envelope of gas and dust, right from the get-go. Scientists clock its nucleus at around 20 kilometers across, roughly the size of Manhattan, making it the biggest interstellar visitor yet. And get this, based on its composition and orbit, it could be billions of years old, potentially 3 billion years older than our own solar system. Imagine that, a relic from the Milky Way's chaotic youth, carrying clues about planet formation in a distant stellar nursery. But what really hooked everyone was its speed and path. At 87 kilometers per second, it could cross the Earth-Moon distance in under 80 minutes. That's not just fast, it's a sprint through our cosmic backyard. Early models showed it barreling toward the inner solar system, swinging by Venus, Mars, and Jupiter without a close shave to Earth. Thank goodness, since we'd love to study it up close without the drama. Its perihelion, the closest point to the Sun, is set for October 30th, 2025, at about 1.4 astronomical units, or roughly 130 million miles away, safely between Mars and Earth's orbits. No Hollywood crash landing here. It's a graceful arc, slingshotting around the Sun before fading into the outer darkness. Yet as telescopes worldwide turn their gaze, subtle behaviors emerge that echoed those earlier visitors. Like Borisov, it's outgassing, releasing carbon dioxide and other volatiles as sunlight warms its icy core, but at rates that suggest a pristine, untouched surface. Spectral analysis from ground-based observatories like Gemini South revealed spikes in ultraviolet energy, hinting at exotic chemistry forged in another star's glow. It's like opening a 4.5 billion-year-old letter from a neighbor we never met, sealed with interstellar frost. As 3I/ATLAS hurtled inward, the James Webb Space Telescope stepped up for a starring role. In late August 2025, JWST's NIRSPEC and MIRI instruments locked on, delivering the sharpest images yet of an interstellar object. What did they find? A nucleus that's not just big but active, with jets of material erupting in rhythmic patterns every 17 minutes or so, according to preliminary data. Not chaotic sprays, but organized bursts, almost like the comet's venting gas in controlled pulses as it navigates the sun's heat. Webb's infrared eyes pierce the coma, spotting complex organics, carbon chains, water ice, and hints of silicates that don't match anything common in our Kuiper belt. These aren't random. They point to formation in a cooler, metal-poor environment, perhaps around a red dwarf star in the Milky Way's outskirts. Fun fact, if you laid all the water locked in 3I/ATLAS across Earth's oceans, it'd raise sea levels by a measurable fraction. Talk about a cosmic delivery service. But here's where it gets intriguing. Those pulses, they're aligned with the comet's spin, suggesting a layered structure, like an onion of ice and rock built over eons. Theoretical models backed by simulations from NASA's Jet Propulsion Laboratory propose that such outgassing could subtly tweak its trajectory, not steering like a ship, but fine-tuning like a sail catching solar wind. It's natural physics, yet it sparks what-if whispers. Could similar mechanics explain Oumuamua's non-gravitational acceleration? We're not saying alien tech, far from it, but these visitors challenge our assumptions about what's normal in space. Smoothly transitioning from Webb's gaze to the red planet's doorstep, let's talk about the Mars flyby, the highlight reel of this cosmic tour. Last week, from October 1st to 7th, 3I/ATLAS made its closest pass to Mars, zipping within 19 million miles, or about 30 million kilometers, a hair's breadth on solar scales. This wasn't a distant wave, it was front-row seats, courtesy of our orbiting sentinels. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter snapped the closest views yet, capturing the comet's fuzzy coma against the rusty horizon. NASA's Mars Reconnaissance Orbiter joined in, its high-rise camera pulling razor-sharp details of the nucleus's rugged surface, craters pocked like an ancient golf ball, with bright streaks of fresh ice. Even China's Tianwen one contributed, detecting faint radio echoes that helped map its shape. No impact drama, thank the stars. Simulations confirmed a safe miss by millions of miles. But the data? Gold. Radar bounces from these craft revealed a metallic glint. Not soft ice, but denser material, perhaps iron-rich from its home system's heavy elements. And those green-tinged jets in amateur images? Likely ionized gases, glowing under solar UV, converging in patterns that mimic thruster exhaust but are purely cometary. Think of it as nature's fireworks. Sunlight sublimates the ice, pressure builds, and boom. Elegant arcs light up the void. For Mars missions, this flyby was a bonus stress test. None of our rovers or landers felt a thing, but the observations bolstered planetary defense protocols. If a real threat ever came, we'd spot it early, just like this. Building on that red planet rendezvous, it's worth comparing 3I/ATLAS to its interstellar siblings, because each one peels back another layer of the galaxy's onion. Remember Oumuamua? That 400-meter-long cigar puzzled us with its tumble and unexpected speed boost, leading Harvard's AV Loeb to float the wild, but evidence-light idea of a light-sail probe. Borisov, on the other hand, was cometary through and through. A 1-kilometer nucleus belching diatomic carbon, smelling like a cosmic distillery. 3I/ATLAS question mark. It's the Goldilocks of the trio, just right. Bigger than both, more active than Oumuamua, and chemically richer than Borisov, with CO2 outgassing rates double what's typical. Data from Hubble's August 2025 imaging pegged its nucleus size precisely at 20 kilometers, tumbling slowly at 0.2 rotations per day, stable enough to preserve its coma without fragmenting. Side by side, these objects tell a story. Interstellar space is littered with ejecta from planetary collisions, and our solar system might have flung out thousands over its lifetime. Fun analogy, it's like finding puzzle pieces from another box scattered on your floor. Each one hints at a bigger picture of exoplanet chaos. Theoretically, if we catch more like this, we could reverse engineer their origins, tracing back to specific star clusters via isotopic fingerprints. Loeb's team at Harvard revisited their papers post-flyby, noting the rhythmic pulses align with natural models. Not engineering, but they leave room for exotic explanations if anomalies pop up. For now, it's science winning over sci-fi, though who knows what perihelion brings. As 3I/ATLAS slings toward its solar close-up, the implications ripple outward like those gas jets, transforming space exploration from telescope peaks to a full-blown treasure hunt. First off, astrobiology gets a boost. Webb's spectra hint at prebiotic molecules, amino acid precursors perhaps, locked in the ice from a water world long gone. If Mars's subsurface harbors microbes, and missions like Perseverance are sniffing for them, this visitor's organics could inspire panspermia debates. Life hopping between stars on icy rafts? It's theoretical, supported by lab simulations in nature showing microbes surviving comet-like conditions, but no direct evidence yet. Then there's planetary science. By studying how 3I/ATLAS interacts with solar wind, we refine models for our own Oort cloud comets, predicting impacts or water deliveries to early Earth. Jupiter's Juno probe will eye it next month, scanning for gravitational wobbles that could reveal hidden mass. And defense? This flyby honed our tracking. Atlas and ESA's network spotted it months early, proving we can marshal global assets fast. Future-wise, imagine dedicated interceptors for the next one. SpaceX's Starship could launch a flyby probe in under a year. For diverse voices in the field, shout out to astronomers like Sarah Seeger at MIT, pushing inclusive models that factor in underrepresented chemistries from metal-poor systems, or indigenous knowledge keepers noting ancient sky patterns that align eerily with these paths. It's not just data, it's a tapestry of human curiosity weaving with the cosmos. Zooming out to the bigger canvas, these interstellar jaunts force us to rethink isolation. Our solar system's a bubble in a frothy galaxy, and 3I/ATLAS is proof. Every 10,000 years or so, one drops in, stirring the pot. Economically, it's spurred investments. NASA's upped funding for wide-field surveys, ESA's plotting Comet Interceptor for 2029. Ethically, as we colonize Mars, events like this underscore stewardship. What if a visitor carried contaminants? Protocols now include bioquarantine sims. And philosophically, it humbles us. A comet from another sun, whispering of lost worlds, reminds beginners and experts alike that space exploration isn't conquest, it's connection. Rhetorical nudge. If this frozen wanderer can bridge light years, what barriers can't we smash here on Earth? Wrapping this cosmic journey, let's crystallize the takeaways from 3I/ATLAS. 1. Interstellar objects are more common than we thought, offering free samples from alien skies. Track them, study them, learn from them. 2. Tech like JWST turns what if into what is, revealing rhythms in the void that echo universal laws. 3. The Mars flyby showed our global teamwork in action, safeguarding assets while grabbing priceless data. And 4. It sparks big questions. Is life a galactic norm? Could we one day hail these visitors instead of waving goodbye? Ponder that as it heads to perihelion. What secrets will the sun coax out next? If you're as hooked as I am on space exploration and interstellar mysteries, hit that subscribe button. We've got Mars mission updates and black holes explained coming soon. Like if this flipped your view of comets from boring rocks to starhoppers, and drop a comment, Oumuamua, Borisov, or 3I/ATLAS. Which interstellar enigma blows your mind most? Check out our playlist on recent space discoveries for more. Thanks for joining the ride. The universe awaits your next question. Clear skies,